All right. Hi, and welcome to the second lecture of week 6, conditional statements to the reconditioning. That's right. Okay, so we're going to talk more about conditional statements. But before that, just a quick note on something that I touched on the previous lecture, and I just kind of want to reiterate and kind of re-solidify that idea, the concept of nothing. All right, so imagine here a function that a function defined as, or define a function called does nothing, which if you see that this is the explanation of what this function does. This function has no parameters, no code in the body, and does absolutely nothing. Or does it? Does it return a value? And all this is commented, so basically this is not code that is going to be executed. So this function, this does nothing function, what does it do? If you have guessed that it does nothing, then you are absolutely correct. Jeez, I don't know why my face is so washed out. But yeah, sorry about that. I don't know why I'm so like pale white. Okay, sorry. Right, so this function does nothing. So obviously there are no statements in the body. There's nothing. There's no code in there. So obviously this function does nothing. Does it return anything? Right. So does it return a value? There's not even a line that says return none. There's nothing. There's no return X, return whatever. But does it actually return anything? The answer is yes. It actually does return something. By default, Python will return none. So if you don't actually include return none, it will actually, in fact, return none all on its own. Right. So you don't. So when you're defining your functions, you don't actually need to write return none if you don't want to. And there's actually a Slack discussion about this this week. You don't have to, but in my opinion, you're always better off writing it and just kind of being explicitly stating it that you should, even if your function returns none, you should specifically state it instead of just leaving it up to the default program behavior. That's my personal preference. That's my opinion, but it's not 100% necessary. The other thing that I want to kind of mention now is that, and I mentioned this last week. So in previous weeks, when I've talked about none, I've talked about like returning none. I've talked about how it returns nothing, and that obviously is not true. None isn't nothing. None is actually a specific type of object that contains none, right? Or it's a none type object. And so effectively it is kind of like nothing, but it's not nothing. Like you need to actually define the nothing, and that nothing is defined as none in Python, right? So in the same way that like when you create a character, a string that like is just quote with like nothing and another quote, like just two quotes next to each other with nothing in the middle, there are no characters there, but you are still creating, and you're basically creating an empty string object, right? And so it's the same. It's a similar kind of idea. So none is a thing that needs to actually be defined. It needs to have, or nothing has to be defined, and so it's defined by none in Python. So just trying to keep that in mind, that none isn't nothing. It's none, right? And in fact, if we do a quick example over here, let's do from. Oh, it should be in the weapons. So don't worry about this part so far. Yeah, don't worry about it. These are just in this week's, in the tutorial that I'm going to do, the coding tutorial that I'll do later this week. We're going to use the weapons.py file, and in that weapons.py file, which you can see over here, there's a function that this is exactly the does nothing function over here. And I'm basically just telling Python that I want to load those functions. So if I actually do the does nothing, if I call the does nothing function, it returns none, or visibly it doesn't return anything, but it actually returns none, right? And so if I were to do does none, print does none, it actually returns none. It actually show you the none that it actually returns. And if you were to Right. So the type of so if you call the does nothing function, whatever it returns an object of class none type, or an object of type none, right? And it returns none. And obviously this none is a specific type of object, which is different from none in quotes, which would be the word none, which would be a string object and not a none type object, right? Okay, so just a quick note on none not being nothing. None is actually something. It is a specific type of object in Python that exists, and is a useful thing that it exists. So just keep that in mind. Okay, so documenting return statements. In your documentation, you should describe the type and meaning of the object that you return. So this is an example of a good return statement, or a good documentation, where you're basically saying your return is going to, or your function is going to return a float that contains an approximation of pi. And the function itself, this is what it does. It basically is, it calculates an approximation of pi by summing up the first n terms of an infinite series. We're not getting to the math, that doesn't really matter. And you're basically saying this function, the parameters, n is the number of terms to sum, the returns, it'll return a float, so an object of type float, containing an approximation of pi, right? So this is what you should be including in your documentation, what your function is actually returning. Okay, so typecasting, and this is sort of relevant for your homework. The only times you need to typecast, or to cast an object into another type, is when you use the input function. So your input, if you're inputting numbers, input will necessarily store them as strings, or return a string object, and so you might need to cast it into an int or a float. Or if you're doing a string concatenation and you're trying to concatenate numbers, you'll need to cast them as strings so that you can actually concatenate them properly. And then also, we'll talk about this later, but also when you read from a file, you might need to do that. Those should be the only times. There are obviously exceptions to that, but at least definitely within this course and in general, that's kind of true. Otherwise, casting outside of those cases are basically unnecessary operations that make your program less readable and less maintainable. So just kind of avoid doing that, and it shouldn't be necessary most of the time. Okay. So we talked about this in the last lecture, the first lecture this week. So the if, else if, elif statements, the else. Yeah, so basically just, and so this is basically a decision with many different options. And so just to kind of refresh your memory, if we're reading this as the way that Python would read this, it would first evaluate the if candy color is equal to red, so your variable candy color, if it contains a string that contains the word red, then this would be true and it would print cherry. It would then basically stop. That'd be the end of this whole if, else if, else block. As soon as one of these returns true, the whole thing stops, right? Say, for example, this candy color wasn't equal to red, then this would be false, and then we move on over here. If else, otherwise, if this is not true, if this candy color is equal to green, then you would print this. If not, then you would test this condition. If not, you would test this condition. If not, so on and so forth, right? And then if none of these, if this is false, if this is false, if this is false, and this is false, then the default other option, the other option, if all of these fail, or not fail, but like if all of these are return false, or if all of these conditions are not met, or all of these conditions are false, then it will print no clue, right? So that's like the default otherwise option, right? So once again, it's important to know that only one of those print statements will actually execute. As soon as one of these returns true, the whole thing will stop after that. It won't read the rest of it after that. So Python enters the first condition that evaluates to true, executes the body of that compound statement, and skips all the rest, right? So, and just like we did with the grocery list example in the previous lecture. All right, so examples of errors in conditionals. So if we look at this is a similar thing to the previous one with one small change, where the else is actually partway through this like block of ifs and elifs, right? Does this make sense? So basically, hopefully the answer should be no, because essentially, it'll read this if this is false. If this is true, it'll print this. Otherwise, if this is false, it'll go to the next one. If false, it'll go this one. If false, it'll go this one, and then it will do this one, right? Because this else encapsulates all other cases, and so it will do this one, and so it will never actually get to this last elif, right? Because this is the one. This condition will have been met because there's no if here. This is the if all of these are not true, then this. And then if you throw another else if, then that doesn't make a whole lot of sense. Python won't ever get to that because it'll always X out of this this conditional at this point over here, right? If this, it'll leave this if statement over here. So yeah, so that doesn't make any sense. So what about this? So again, this shouldn't make a whole lot of sense because once again, it'll read this. If this is false, it'll come to here, be like, okay, well, these two are false, and so I'm going to print this, right? This is the all other cases situation. And so again, it won't ever get to this other else, right? So two else's don't make a whole lot of sense. Yeah, you should basically just never use that. The else should always be the last one in your series of if, else, if, and else's. There should only be one else, and it should be the last one, right? Which kind of makes sense because it's kind of the not the garbage bin, but it's like the if yeah, actually, so if you imagine like kind of trickling down, right? It's like you get to this last one, it's like, well, this is it, right? This is the last possible place you could go to, and then everything else goes in there, right? Okay. So what about this? Right. So in this case over here, what the difference is the else here, there's an extra condition over here. So does that make any sense? Not really, right? Because else if you're specifically using otherwise if this condition is true, right? So an else doesn't have any conditions. The else is the default option if all the other things are false. And so adding a condition here doesn't make any sense. Once again, because the else statement is a all other cases, it doesn't have a condition. It shouldn't have a condition. It should just be else whatever happens, right? So if you wanted this to be like a condition, then this else should actually be an elif, not an else, right? So yeah, so if there's a condition, it should be or only ifs and elifs should have condition, else's shouldn't have any conditions. And if you want it to be else and a condition, then it should be an elif, right? Okay. Logical operators. So to make our Boolean expressions more interesting, we have a set of logical operators. So this is kind of a new concept that we're tacking on, or we kind of talked about it a little bit in the previous lecture, but yeah. So the and, or, and not logical operators are things that you can basically combine comparisons together, right? So you can use those with comparison operators, and you can use any combination, mix and match them however you want. Yeah, and that's fine. Yeah, and also with your Boolean expressions, you can use parentheses. That's fine, and for clarity and just for order of operation. So you can definitely do that. So if we read this, you're basically saying here if x greater than 50 and x smaller than 100, right? So essentially you're saying if this is true and this is true, so both of these need to be true in order for the whole expression, the whole Boolean expression to be true. So you can think about this like solving smaller parts of a larger formula. This would evaluate to true, this would evaluate to true, and test whether this is true and this is true. And if that's the case, then the whole thing evaluates as true, right? That's effectively how Python would read that. So this would only be true if both these conditions are met, and then it would print this. Or is different in the sense where again, it would evaluate whether this is true. It would evaluate whether this is true, and it only needs one of them to be true, right? So if this one is true, or if this one is true, then it will print this. This could be true and false. This could be false and true, or both could be true. All of those would return a true for this or operator, right? Not is basically like flipping a true to a false or a false to a true, right? It just kind of flips a switch on whatever the not refers to. So here it will evaluate this expression over here is x greater than 100. If x is in fact greater than 100, this would be true. And then you throw in a not, then your true becomes a false. And so this would not get printed. If x were actually smaller than 100, wait, I'm sorry, I may have said that backwards. So if x is, yeah, no, I'm sorry. Yeah, if x is smaller than 100, this would be false. And so this false with a not would become a true, and then it would actually print this. So it only print this if x is smaller than 100. So yeah, so it's essentially the inverse of whatever the not refers to. Okay. And again, like thinking about this as a formula, it would evaluate this part first, and then if you had, for example, this whole thing in parentheses with a not in front, then it would evaluate everything within that big parenthesis and then flip it with a not to whatever the inverse of that was, right? So so again, that's same logic applies as normal math, using parentheses in the same way. You evaluate the smaller portions first, and then you kind of evaluate the rest after that. Okay. So examples of logical operators. So you could do, for example, if you wanted to like test whether an age were between 12 and 20, you could do if age is greater than 12 and age smaller than 20, then essentially, if the number age is like, 10, this would be false because this condition is not met. It doesn't matter if this is true, both need to be true. And same thing, if age were equal to 22, it would also be false because this is false and both need to be true. And here, for example, if ounces were equal to 12 or equal to 20, so if ounces equal to any value other than 12 or 20, then this would be false. If ounces is equal to 12, this would be true, this would be false, but because this is an or statement, it would only need one to be true, and so this whole statement would be true, right? Same thing if ounces were equal to 20, but if ounces is equal to 19 or 10 or whatever, this would be false. So color equals blue. So if your color is actually, if your color refers to a string with the word blue in it, then this would be true. But then you throw a not in front of it, you flip it, that true becomes a false, and then you wouldn't print this. And then vice versa, this would only get printed if the color is not actually equal to blue, right? So color not equal to blue. This would in fact be the equivalent of if you remove the not and did exclamation mark equal, which is not equal, you would get effectively the same result, right? Oh yeah, which is what you have done here. Yeah, so these two things are basically equivalent. You can put multiple nots one after the other, and they basically cancel each other out. So this is actually 3 knots one after the other, which is unnecessarily complicated. So definitely you should not have this in your code like this. This doesn't make a whole lot of sense. But essentially, if we think about this, if color referred to a string with the word blue, it would test this first. So blue not equals to blue, so that would be false, right? Because it is equal to blue. And then this first not would turn it back to true, and the second not would turn it back to false, right? And so this would not get printed. If this were anything except the word blue, then this would be true, and then false, and then true again with the second not, right? Okay, and same thing down here. So this is a combination of multiple things going on. So if we evaluate that, the first thing we're looking at over here is color equal to green, and is pen size greater than 5, right? So imagine our turtle has its pen set to pen size 6, and the color of the pen is green. So this would be true, and this would also be true. And so this whole and statement, because both sub-statements are true, this whole thing would also be true. And then you threw a not in front of it, and so it would be false, right? Conversely, if the color were blue and the pen size were greater than 5, this would be false, this would be true. The whole and statement would be false, and then throw a not in front of it, and then this would be true and get printed, right? Hopefully that'll kind of make sense. Okay. So logical operators. So one thing to be careful of is logical operators, making sure that your logic is actually sound. These things won't throw errors, but they're definitely not logically sound. So if you look at this, we're saying if age is smaller than 12 and greater than 20, effectively that's impossible, right? There's no number that fits both of these things. If age is smaller than 12, it's necessarily not greater than 20 and vice versa. And so there's no way that both of these could be true. And this is an and statement, and both need to be true for this to return true. And so this would necessarily return false. And so this would never happen, which is why it says, that's really amazing. In other words, impossible, right? Here, you're basically asking if age is smaller than 12 and age smaller than 20. I mean, effectively, this is the same thing. If the number is smaller than 20, if the number is smaller than 12, it's necessarily smaller than 20, and so this is redundant, right? You don't actually need this, because if this is true, this is necessarily true, and so this part of it is not important, right? All right, over here, if age smaller than 20 or age smaller than 12, so just one of these things needs to be true. Once again, this is sort of redundant. As long as the age is smaller than 20, this will be true. And so this is redundant information. This is not actually adding anything, because if one of these two is true, then the whole or statement is going to be true. And so you only really need this, because this is just kind of it's just redundant. And so hence the Okay, so just kind of be careful when you're making your logic statements. None of these things will throw errors, but they don't make a whole lot of sense on their own. The logic doesn't make sense. Okay, so this is yet another example. So this is an example, a code that assigns letter values to grades. And it's effectively asking, so if the grade is greater or equal to 90, print A. Else if grade smaller than 90 and greater or equal than 80, print B. Else if, you get the idea. And so it's basically filtering through all the grade and then assigning a letter value to those grades, ending in else if this is not true, this final statement over here, where grade is between 70 and 60. If that's not true, and which necessarily means that everything above it is also not true, then just print an E, because essentially because the grade is necessarily smaller than 60 or 60, smaller than 60. Okay, so effectively this code works. So there's nothing inherently wrong with this code, right? But the question is there anything redundant in this code? Do you actually need all of this, right? And kind of a subsection or a sub-question is, why didn't I have this, another else if, grade smaller than 60? Why did I use else instead of using this, right? So the answer to that first part is you don't actually need, you don't actually need a conditional here, because over here, because this last statement is already asking if grade is greater or equal to 60, and all of the other conditions above that assume that grade is greater than 60, then we know that if this is false, if this is false, if this is false, and this is false, grade is necessarily smaller than 60, and so everything else, every other possible case, is going to print an E, right? So you don't actually need to add another condition here. By default, everything else will be an E, right? The other part of this that's redundant is, so over here in my first statement, I'm asking, is grade greater or equal than 90, right? And so if this is false, this second part over here that's asking if grade is smaller than 90 is not necessary, right? By default, if this was false, this is going to be true. Um, and um, and the only way that I get to this condition is if this is false. So this is necessarily false. If Python is at the point of reading this part of the code, this was necessarily false. And so this is necessarily true, right? Or this part of this else if condition is true, at least. And so the only part we really need is this part over here. That's the only kind of non-redundant part. So it's the same ideas over here. Parts of these conditions are necessary, and so it's the same idea over here. You don't need all of these conditions, so you can simplify the code and make it a little cleaner, a little bit nicer. And so you could do something like this, where you're basically just doing grade greater or equal to 90, greater or equal to 80, greater or equal to 70, 60, and then else, everything else gets an E, right? And so you can think of this as, filtering like a sieve, right? So, or yeah, I forget the name of those, but like the filters with like increasing finer meshes. Yeah, so essentially that's what you're doing, right? So in the first one, you have a really wide mesh, and so everything that like stays up there is going to be greater than 90. Everything that falls below is necessarily going to be smaller than 90, and so you shake that one, and then so on and so forth. So it's the same idea over here. That's effectively what we're doing, and then the else at the end is just everything that's like smaller than the smallest mesh that we have just falls out of it, and then that's what our printee is over there, right? And so that's why we don't need a condition over here. Again, there's nothing inherently wrong with adding those extra conditions here. It's just not necessary, and it makes your code a little more heavy and a little less clear and a little less nice and easy to read, right? So effectively, yeah, just shorter and more clear. Okay. Conditionals are sometimes called selection statements because they're about choosing which code to execute based on some test or some condition, right? Yeah, so effectively that's what we've been talking about. When we talk about filtering or selecting, or so just kind of a note that conditionals are sometimes called selection statements. If statements versus for loops. So it can be confusing. It can be easy to confuse the two. And so just kind of a quick note on that. If statements, they're for choosing whether or not to execute code based on a test, right? So if is like, if this condition is true, run this code. If that's not true, then don't run it at all, right? So it's kind of a switch, like imagine like a train track, like moving the track, like if you want the train to go over here or not, like that's basically, it's like a bifurcation, yes, no, and then if yes, then you take that loop, and if no, then you just kind of go straight past it, right? Sorry, I shouldn't have used loop in that analogy because that's confusing with like for loops, but sorry. For loops are necessarily for repeating code. So for loops, the code in the for loop will necessarily run, right? In if statement, the code may or may not run depending on the condition of the if statement. For loops, the code always runs and will run as many times as you ask it to repeat in your for statement, right? Okay. If you want the option to skip a piece of code, then you would use an if statement. If you want a section of code to execute more than once, use a for loop, right? So that's what we've been talking about. Okay, so that sort of concludes the review portion, or review and slightly adding on to what we've already talked about before. I just want to mention, so this is basically, I'm going to be talking about yeah, so in this week's coding tutorial, I'm going to be talking about the weapons.py file with all the different functions that are in there, which is over here. So there's a whole bunch of functions, and yeah, so we'll do that then. If I remember correctly, we're basically going to be playing a complicated version of rock, paper, scissors. But yeah, let's not worry about that for now. But next, we're going to basically go through an example and talk about something called short circuit evaluation. So that's what we're doing next. Oh, and Boolean expressions. So sorry, yeah, we're going to talk about Boolean expressions and conditional statements, and then we're going to go through an example and go talk about short circuit evaluation. So Boolean expressions. So what do Boolean expressions do, right? So So effectively, a Boolean expression always evaluates to a single true or a single false, right? That's the end result of a Boolean expression is always going to be either true or false. There's nothing else it can be, right? So no matter how complicated the expression, no matter how complicated the expression is, it still always boils down to either true or false, right? Right, and Python evaluates a condition expression executes a body only if the condition evaluates is true, right? So what we could do, so instead of writing a complicated condition, a complicated Boolean expression, what we could do is just like say if true, print this, right? And if true is necessarily going to be true because we're essentially telling the if that the condition is true, right? So we're skipping the whole condition part of it and we're just telling it it's true. Don't worry about it. Print this thing. Now, obviously, this is not useful way to code things because this is always going to be true, and so this will all be printed, and so the if statement here is not necessary. In the same way that we could do if false, print this. We're telling the if that the condition is false. Without any condition, it just is false, and so this will never get printed, right? Yeah, but effectively, when Python is reading your Boolean expression, it evaluates it and comes out to either a true or a false, and then it's basically the equivalent of this. It's going to be true, it'll print it. If it's false, it'll print it. Or so, if it's false, it won't print it. Okay, Boolean expressions with logical operators. So sometimes Boolean expressions can be confusing. So it can be helpful to kind of read it out loud in this form, though I find that the reading out loud to be a little bit confusing, but I think that's just personal preference. So if you just kind of read it out, if is it the case that both this and this are true, and so that would be true. Is it the case that either this or that is true? So basically, you're asking, this and this, so both need to be true. This or this, one of them needs to be true. Yeah, so for example, X or Y reads as, is it the case that either X or Y is true? So as long as the X or Y is true, then this will return true or evaluate as true. False or true, is it the case that either false or true is true? So one of these is true, so it would evaluate as true. Is it the case that both X and Y are true? So X and Y, so both of these would have to be true for this to evaluate as true. And is it the case that both true and false are true? That is obviously false because one of these is not true. So, true and false, both true and false aren't true. So this is false, right? And so it can be useful sort of instead of sort of reading out, it can be useful to kind of think of it as a in terms of logic or truth tables. And so this is essentially like all possible outcomes for and, or, and not. So if in the case of and, if X and Y are true, so X is true, Y is true, then it would evaluate as true. If X is true and X is false, or X is false and Y is true, or X and Y are both false, all of these evaluate as false for the and, right? For the or, if X is true and Y is true, it would evaluate as true. If X is true and Y is false, then it would evaluate as true because one of these is true. This or this is true, so yes, that's true. If X is false and Y is true, then that would evaluate as true. And if X and Y are both false, then it would evaluate as false. That's essentially the only case where or would return false is if both of these are false, right? And as I mentioned, the not, if X is true, then not X would be false. If X is false, then not X would be true, right? So it's essentially like flipping the switch on, flipping the false to a true and true to false. All right, nested conditionals. So the body of conditional statement can, of course, contain other conditional statements. We've kind of done this already, and that's essentially something called nesting. So in this case, this if condition is nested within this other if, and of course this can be as complicated or whatever as you want. You can have an if within an if within an if with an else if and then an else and then an if in a lower one indent less, so on and so forth. You can basically nest and build really complicated conditional statements if you want, or if statements. Right, you can also do this, if this, if this, if this, if this, if this, and then else if, in this case, the else would apply if this one is, because the if and the else are at the same level of indent, and so if this returns false, then this would happen, this else. These ifs would only happen if this were true. These ifs, these three ifs would only happen if this if, well, if both the first ifs were true, so on and so forth, right? So you can certainly nest as deeply as you need to. Conditional statement can contain as many statements as you need it to. A compound statement is a statement. However, if your code actually looks like this, there's probably a much better way to actually kind of do that, right? This is unnecessarily complicated. There's probably a much better way to do things. All right, and in general, usually when you're coding, your first kind of shot at coding is probably not going to be the prettiest or most efficient or the most kind of concise way to code. And so oftentimes, you'll write it out one way and be like, oh, actually I can like simplify it by doing this. That's a totally normal thing that happens. Okay, so we're going to talk about an example real quick. So in this example, we're talking about amusement park rides. So we own an amusement park. And there are rides in that amusement park. And so we have two rides, one ride that's called Zipper, one ride that's called Cycle Jump. There are two age groups. We basically can classify people who come to our amusement park as either adults or children, or adult and child. The Zipper ride is restricted to adults, and the Cycle Jump is restricted to children, right? So only adults can ride the Zipper, and only children can ride the Cycle Jump. So we're basically going to write a function that takes the name of the ride and prints the age group that can ride it, right? And so effectively, this is what that would look like, or could look like. So we're essentially defining a function called canRide, and we're passing the argument ride, or we have the parameter ride to it that we're going to pass an argument to. And we're basically saying if ride equals to Cycle Jump, then print children only. Else if ride equals to Zipper, adults only. And then if the ride is neither equal to Cycle Jump nor Zipper, so all other cases, anything else other than Cycle Jump or Zipper, then it'll print unidentified ride name. Right? And the function returns none because we're not necessarily returning anything, we're just printing stuff out, right? So if we look at this in our main, if we have canRide Zipper with 1p, what do you think this will print out? So if your answer was unidentified ride name, that is correct, because Zipper with 1p is not equal to this, is not equal to that, and so it falls into the else bucket, and then the default other option, and so it'll print out unidentified ride name. If you do canRide Zipper with 2p's, then it would encounter this first, a ride equals Cycle Jump, that would be false. Else if ride equals to Zipper, this would be true, and so it would print adults only. And then the last one, canRide Cycle Jump, it would test whether ride equals Cycle Jump, it would evaluate to true, and then it would print this and then skip all the rest after that, right? All right, so let's extend our function to take an age parameter. So we're going to ask not only the name of the ride, but the age of the person going on the ride. The age parameter will either be adult or child, so only two possible values. And we'll return, will the function return? So the function will return either yes or no, depending on whether the given age group can ride the given ride, right? So the function is going to either return yes or no, depending on whether the ride and the age of the person. So that function could look like this, where like we mentioned, the canRide would have two parameters: the ride, the name of the ride, and age, the age of the person. And then essentially we're creating a variable called result, and that's what we're going to return. We're going to return the whatever the result of result is. And so if we look through this, we're basically saying if ride equals to Cycle Jump, and age of the child, or age is equal to child, then the result will be yes, because only children can ride the cycle jump. If ride equals cycle jump and age adult, and the age is adult, the answer would be no, because adults can't go on the cycle jump, so on and so forth, right? Okay, so if we look at these examples, so can ride, child, and zipper. So immediately we might notice that there's a problem here. We're at the parameters we're trying to pass. Remember, the arguments are passed in order to the parameters, and so ride would refer to child, and age would refer to zipper. And so in that case, is ride equal to cycle jump? No, it's equal to child, so that would be false, and this is an and statement. And so necessarily that would be false. Same thing here, ride is equal to child, and so this would necessarily be false, and this is also an and statement. So we know that this would necessarily be false. Same thing here and same thing here, right? So ride is not equal to cycle jump or zipper, so all of these things would be false, and so we'd end up in the else category, where the result would be unidentified ride name, right? And child is an unidentified ride name. Child isn't a ride, it's an age, right? Okay, so in this other example, if we're saying can ride, zipper, and child, same thing. Again, think about this, as kind of filtering through different layers, different sizes of mesh. So the first thing we're asking is ride equal to cycle jump? No, it's equal to zipper, so this is necessarily false. Is ride equal to cycle jump? Still no, so false. Is ride equal to zipper? Yes. And age is equal to adult? No. So again, this is an and statement. Both need to be true for this whole condition to be true, and one of these is false. Age is not equal to adult, and so this would be false. Ride equals to zipper? Yes. Age equal to zipper? Yes. So both of these are going to be true. It's an and statement. This and this is true, and so result would be assigned the value no. And then we would skip the else, because we've already found one condition that was true. And so it would return whatever the result refers to. In this case, it would be no, right? So the return of this would be no. And then over here, if we are doing can ride, zipper, and adult, same deal. Ride is not equal to cycle jump, so we skip this. Ride is not equal to cycle jump, so we skip that. Ride is equal to zipper. Yes, that is true. And age equals to adult. Yes, that is also true. Result would then be assigned the value yes, and then everything else gets skipped. And then return, the function returns result, which is assigned the value yes. And so the function would return yes, right? Okay, so here essentially we've enumerated every possible case, right? We basically did every possible combination of ride and age, which is fine. But is there a simpler, more neater, more cleaner way of writing all of this, right? Instead of doing every possible combination, you can imagine if you have like 5 rides and 3 different ages, you start to have a lot of code, and that's obviously not super efficient and not super clean. So instead, you could do it this way, where effectively you're saying, is ride equal to cycle jump? And then within that if, you add another if, which tests whether the age is child. Yes, else, no, right? And so you're first asking if the ride is cycle jump. Yes. Then you go through here. If it's no, then you immediately skip to this one. Is ride equal to zipper? Yes or no, so on and so forth, right? And so if we look at this, if we do, once again, the same examples, if we do child and zipper, child being the argument passed to ride, is ride equal to cycle jump? No, ride is going to be essentially referring to child. And so child does not equal cycle jump, so that's going to be false. Child is also not equal to zipper, so that's going to be false. And then it will fall into the else and return unidentified ride name, right? And so it doesn't even need to go to the rest of it. If we're doing can ride, zipper, and child, is ride equal to cycle jump? No, ride is equal to zipper. Is ride equal to zipper? Yes, so true. And then within that it'll ask next, or within that else if, it'll ask is, if age is equal to adult. So in this case, age is equal to child, so that'll be no, and so it'll skip everything else, or it'll skip this, fall into the else, and then the result will be assigned the value no, and then it'll skip this else and go into return result. which result now we'll refer to no. And last example is zipper, an adult is right equal to cycle jump, no. Is right equal to zipper, yes. Is age equal to adult, yes. Result gets assigned yes, and then it'll return yes, right? Okay, sorry, so this is more of a kind of a divide and conquer approach. We first split things up by ride and then by age group. And so yeah, so it kind of like simplifies things a little bit. Could we have split things up by age first? Yeah, absolutely. There's no reason we couldn't do that. It's just a matter of like testing one conditioning first and then not bothering to test like having multiple complicated conditions and just nesting instead of building complicated conditional statements, right? All right, so let's assume now that our park is doing so well that we can afford to buy 2 more rides. Our children rides are making the most money, and we do like making money, so we buy 2 more rides for the children. So we add 2 more rides, and so we have a total of 3 rides for children that are children only. Cycle jump, which we already had, quad runner, and kid wheel. So we have 3 rides for children and 1 ride for adults. So if we're updating the function that we had, so this is the first function that we wrote where we had everything kind of written out, all the possible conditions. So you can see that it kind of stacks up really quickly, right? You have a lot of conditions. As you start adding more rides and more things, your code gets a lot more complicated and a lot longer and just a lot more. I mean, that's a lot to kind of take in at once, right? Alternatively, what you could do instead is, if ride, if you break it down by ride first and then age, you could then have an or statement. If ride is equal to cycle jump or quad runner or kid wheel, then you can test the age after that and then get a yes or no. Else, if the ride is equal to zipper, then you can test the age and that's it, right? So instead of like adding, lines and lines of code over here, you can just add a few conditional statements over here, a few ors over here, and you get the same result. So essentially we're adding 2 ors to our first condition, 1 for each ride. Like I mentioned, often the first solution a programmer comes up with is not the best solution. Oftentimes we write a code. So, writing this code when you only have 2 rides and 2 ages, that's not so bad. It's fine. But then, you start adding on stuff like adding more rides and things get more complicated. And then this starts looking super messy. And you're like, oh, shoot, I shouldn't have done that. Let me build that in a smarter, tidier kind of way, right? Yeah, and the same thing. Essentially, we're trying to build code that's easy for us to understand, easy to debug, and easy to make changes to. Like here, if we want to add more rides after this, it's a lot easier. We can just add more ors to either here or here, easy peasy, right? And in this case, so before it didn't matter if you did ride or age first because there's only 2 possible options for age or ride. Here it starts to make sense to have ride first because you can have just 1 or statement over here. Otherwise you'd have to have, if this or this or this or this. Actually, no, I think that doesn't matter. Come to think of it, I think it still doesn't matter. Yeah, no, it doesn't matter at all. I'm sorry about that. Once again, it's been a long day. It doesn't matter. So the using ride or age first, it doesn't matter at all. Okay, so moving on to short circuit evaluation. So imagine that I make the following statement, following offer to every person in the class. So I'm saying perform the following math by hand with a piece of chalk on the chalkboard, or more realistically, a piece of or a marker on a whiteboard or whatever, doesn't matter. In COVID Zoom times, probably like with a annotation tool on Zoom. Anyway, and if the condition evaluates to true, I'll do what it tells me to do, which is buy you a case of root beer. Because I'm, this is a class, I won't buy you beer, just root beer instead. Okay. So we have this condition over here where we're saying 2 + 3 equals 6, and this long complicated equation over here. So how much time are you willing to spend performing that second calculation, right? So obviously this is going to be a lot easier to calculate than this, right? And we know that this is an and statement, and so both this and this need to be true. So if you're like me and you're a little bit lazy, you'd think to yourself, I just need to prove one of these is wrong. And looking at this, I can pretty clearly see that 2 plus 3 does not equal to 6. This will necessarily be false. And so there's no point in calculating this because this is false. This whole and statement will also be false necessarily, right? Yeah, so Python is also smart lazy, like us. When it evaluates a Boolean expression, Python basically stops working as soon as it knows the answer, right? So in this case, it would read this, like, oh, this is false, done, moving on to the next thing. And that is basically what's known as short circuit evaluation. Okay, so if we have this function over here where we have a function that's defined as is adult, we're basically testing if adult is greater or equal to 18. So if the parameter age is greater or equal than 18, if they're an adult, then we assign true, or we assign true to adult, and print can write adult rides, else cannot write adult rides, right? And it'll return the value of adult, which by default we're setting to false. So when we call the function, it'll assign the value of false to adult, test whether age is greater or equal to 18. If yes, it'll assign true. It'll assign true to adult, then print can write adult rides, and otherwise cannot write adult rides, and then return adult, which if this was false, adult won't be assigned true, and it will be initially set as false, and so we'll return false, right? Okay. In our main, we have this going on. We're creating a variable called the height, assigning the value 55 to it, and then creating a variable called the age and assigning 19 to it. And then here we have an if statement. If height is greater or equal than 60, or is adult equals age, print height equals whatever, all right? So if you are like me in Python and are lazy, you would first read this thing and test, is height greater or equal than 60? Height is currently assigned the value 55, and so this is false. Right. But this is an or statement. And so you would have to go and read this is adult, and then age is 19. We're passing this to this, and so this would be true. So we have a false and a true, and so this would evaluate in total as true, and then would print height is 55, age is 19, right? However, if height were equal to 64 instead of 55, then it would read this if statement, height greater than 60, true. Then it doesn't need to read this, right? Because it's an or statement, just one of these needs to be true. And so, and this is true, and so the rest of it doesn't matter. And so it would never actually run the is adult function. Yeah, the is adult might not happen, right? So, yeah, so that's not ideal, right? So and so essentially that's called short circuit evaluation, and sometimes it can lead to tricky things and confuse, or it can lead your code to do things that you don't expect it to do, right? And so effectively, you're better off writing clear, straightforward code. And so this is kind of an example of what not to do. Essentially, you want your conditions, so you want to think about your conditions and have them set up in a way that only predictable things will happen, right? Right, and so essentially you want to avoid doing things with side effects in your conditional state, in conditional expressions. Here, essentially, because of because of these two conditions and using an or statement here, you're not necessarily, you're basically potentially just using the height and kind of ignoring the age, which is probably not what you intended to do, right? And so you just need to be careful. The point here is only just be careful when you're creating logical statements that you think of all possible outcomes and you're okay with the result of all possible outcomes, right? Yeah, so that's kind of the idea. And just kind of a quick note. So I mentioned here, having side effects in your conditional expressions. And so essentially side effects are essentially when a function or expression alters the global state. That's not what I want to do. Of the program, essentially leaves the program in a different state than it found it in, and that can include printing things. And so essentially, side effects are essentially things that, yeah, basically just when a function expression alters the global state of the program. Yeah, let's not go further than that into it. Yeah. Okay, and that is pretty much that for this week. That's a slightly abrupt end, but that's basically it for this week. I know that was a lot, and we spent a lot of time talking about conditional statements and kind of going through kind of the logic of them all, and that's fine. But it's kind of an important part of coding, so that's why we're dedicating so much time to it. And so it's probably a good thing for you guys to get comfortable and really familiar with it. It's a really important thing. All right, I will see you in the coding tutorial next.